Hello, my mathematicians. Hey, everybody. I'm not sure we actually finished 5.4, and with me being away for a couple of days and not feeling great, I wanted to make sure we had a full explanation of kind of what's going on with the slope formula. So we're going to take a look at this, and we're going to try to get this done in 15 minutes, which is the limit of my video length, so it shouldn't be too long. So one of the learning goals, we're going to try to determine the formulas for the slope of a line segment and use it to find the slope of a line. And hopefully by the end of this, you'll be able to calculate the slope to the line which passes through a point and has a certain slope or a certain rise and run. And if we remember, we said a couple of days ago that slope equals rise over run. So how much does it go up compared to how much does it go over? And the idea is that this is on a straight line. This only works with straight lines, so I'm going to change my colors here for a little bit. So this would have to be a straight line. So how much does a straight line go up and how much does a straight line go over? Now we could have a positive slope, a negative slope, a zero fun slope, and an undefined slope. Remember the video of Slope Dude as we looked at the different types of slopes. So we're going to look at this question. We're going to try to determine this line, the slope of a line that passes through 1.13, sorry, 0.13 and 0.47. So the first thing I want to do is I want to graph these. So I'm going to go, okay, here's 1, here's 3. Let's put a point there. We're going to go to 0.4 and 7, which will be up here. I'm going to grab my line tool so I can actually go through this the best I can. And that's pretty close enough for what I need to do. And I've got my line. So we're going to determine, and I'm going to look at this and go, okay, well, let me get my pen back. I'm going up 1, 2, 3, 4. So my rise is 4. And my run, I'm going to change colors for a second. My run is 1, 2, 3. So my run is 3. So my slope is 4 over 3. And it's okay for us to do this while it's graphing, and we can graph it and we can check it out. But it's not always the easiest way for us to figure this out. But we're going to look at a couple of things that are going to make it a little bit easier so we don't actually have to graph it. So what I want to do first of all is go, okay, this is point 1. So this is x1 and x and y1. And then this is x2 and y2. So I'm just going to go, okay, that's x1, that's y1, x2, y2. So kind of remember that. We've got our, if I go back over here, this was my rise, and this was my run. Now, I'm not sure if I could have done it on a different point. Maybe I could have done this point and another point over here. I'm not sure exactly how my line works out, but it doesn't have to be just these 2 points. It's any 2 points on a line. We should get the same slope. So our question is, if I scroll down, is there a way to find the slope without graphing the line? And our quick answer is yes, there is. And of course there is, otherwise we wouldn't be asking the question. So we are going to look at rise, which is the difference in y values. So difference in y values from point 2 to point 1. It's a bad one, sorry about that. So I'm going to take y2 minus y1. And we'll look at the numbers in a second. Minus y1. y2 minus y1. Remember we talked about a Greek word delta. And that delta in the Greek, in the mathematical sense, means change. So what's the change in the y value from one point to the other, which is our run? I'm going to go over here, which is our rise. We're going to go for our run. And run is the difference in x value from point 2 to point 1. That's a better one. So remember that was a y up here. This is going to be an x, x2 minus x1, x1. Tough to draw on the stylus. So that's our formula. So we're going to look at how we can use this example. Well, we know that our points that we used, we had 0.13, and we had, I think it was 0.47, if that's what I recall from up above. Yep. So we could look at it this way as what's the change in y value? Let me change my colors while I'm at it. Well, our change in y values, if we looked at y, let me get a smaller, y2 minus y1, so it would be y2 minus y1, which would be 7 minus 3, which equals 4. And then we had what's the change in their x values from those 2 points, so x2 minus x1. Again, that's an x. So we have 4 minus 1, which equals 3. And we notice that our slope up here, we've determined our rise and our run, and that's going to equal 4 over 3. So I'm just going to go over here, equals 4 over 3. Well, let's look at the slope formula. So we're going to try to determine the slope of a line that passes through any 2 points. And if we have point 1, we're going to say, well, x1, comma, y1, and we've got x2, comma, y2. Well, slope, and we use the letter m to represent slope. Remember that one, that's going to be important. The formula for slope is I'm going to take y2 minus y1. Let me undo that, I made a mess there. y2 minus y1 over x2 minus x1. And if we use this example that we've just done, let me change color so we can see it a little bit better. We can say, well, we kind of did this above, and we can say that our point was, and we see it over here, right? We see that over here. That's point, this is point 2, our second point. This is point 1 over here. So we're going to take y2, which is 7, minus 3 over x2, which is 4, minus 1. 7 minus 3 is 4, and 4 minus 1 is 3. So our slope for this line is 4 over 3. So we're going to go down, and we see that this is our base formula for how do we calculate the slope of a straight line. So m, or slope, equals the change in y divided by the change in x. We're going to go check and see if we can do some of these practice questions. Let me get to my next page. So if we want to keep using that formula and say m equals, well, this is point number 2, right? And this is point number 1. So if it's y2 would be 8. y1 would be 4 over x2, which would be 0, minus 2. So here we're going to have 4 over minus 2. And again, if we have slopes, we want to reduce these. We want to get these. We like slopes as fractions, but we want to reduce them as much as possible. So we're going to say, well, 4 over negative 2 was the same as 2 over negative 1, which actually equals negative 2. So we got a slope of negative 2 for that one. So we have to remember to reduce. We got to be careful with the negative piece too. Let's do a couple more examples. And then we'll go on. This might be a 2-video lesson just based on time that I'm taking up. So here we're going to say, well, this is point 2. This is point 1. So y, I'm going to do my formula here just to remind us, y2 minus y1 over x2 minus x1. And then we've got to make sure we keep these in the same order, right? So we've got to have our y's as the first number, our 2's as the first number, and our 1's as the second number. So y2 is negative 1 minus 9 over 5 minus a minus 4. I'm going to put minus 4 in brackets just so that we can see that something weird's going on and we got 2 negatives in a row. Negative 1 minus 9 is negative 10. And here we've got 5 minus 4 minus a negative 4, which ends up being the same as 5 plus 4, which equals negative 10 over 9 as our slope. So we've got that one. And again, we've got to be careful with these negatives, right? We've got to realize we have a negative number, we're going to have a negative slope. I'm going to pause the video for a moment and I'm going to finish some of these ones down here below, and then you can also catch up with those. And then I'll come back for the last part. I'm just going to play the video for just a moment and you can pause it to check your answers with these couple of examples. A couple things I want you to notice though, right here, we have an undefined slope. Anything divided by 0 is undefined. This is when slope dude was going straight down, right? That's an undefined slope. It's anything divided by 0. And notice that we can have positive slopes. We can have slopes that are whole numbers and slopes that are fractions. So scroll down in a moment and I'll get back to you. And for the next couple, you can see here that we have a negative slope, which means it's going to go from left to right. It's going down. That's a negative slope. And over here, we have something going through the origin. 0, 0 is our origin. Okay, and we can still have a positive slope. And remember to reduce the fraction. So here I got rid of my negative signs. I had a negative divided by a negative, which ends up being 10 over 4. And I reduce that to being 5 over 2, or 5 halves. I'm going to stop this video. I'm going to make a second one to take up page 2, or page 3 rather, of lesson 5.4. So I'll be back with you in a moment. And everybody, I'm back for part 2. So we're going to go, part 1 is up there. We're going to go to part 2. I'm going to switch my page. Let me change my color. Let's go with like an orange or something like that. And all right, here we go. So part 2 is now we're saying given a point on the line and the slope of the line, we're going to try and find another point on that line. So we know that, if we remember back just a little while ago, we said slope is equal to the rise over run, and we can draw the graph of a line. So we can draw it on there. We can use a formula to check. This is our slope formula. And if we have 2 points, and here we need to have 2 points to be able to do this. So if I had, so given a point on the line, which we are given right here, and the slope of a line, which we are given right here, can we find another point in that line? So let's see what we can do here. So we know, and I'm going to draw this first. So it's -4, -1. So here's our first point, and our slope is 3. If we have a slope of 3, well, really, we like slopes to be in fractions. At least I like them to be in fractions because I know that this is my rise and this is my run. So, okay, so from this point I go up 1, 2, 3, and I should just have to go over 1. And this should be my slope. Let's see if I can get something that I like here. I don't want it to be super thick. But let's see if that's going to work. All right, so I'm through those 2 points. We know that lines go on forever. So if I represent a line that goes on forever, I'm going to put some arrows on it. And let's see what we can do with a calculation. And we know that our answers might differ a little bit depending on what point we start on our line. But our slope will always be the same. But we can find more stuff. We can find another point. So I could have extended this line. Let's see if I can here. 1 second. Let me get my line tool back here. And I could extend this line. And I could extend, sorry, I'm not extending this very well. No, it's not extending at all. There we go. I could have extended it that way, and I'm not sure how accurate I am there, but we're going to look up here, and I found another point in my line because I went up 3 and over 1 for that one. So I had I think my other point, another good point would be, let me get my pen back. If I look at this, this would be -1, -2, -3, and up to, so I think -3, -2 is another point on my line. So -3 and 2. Now what I could do to make sure is I can plug these 2 points in, so point 1 and point 2, and plug them into my slope formula and make sure that I have it. So let me just verify this. So slope equals y2, which is 2, minus y1, which is a -1. And I'm going to divide that by x2, which is -3, minus a -4. Oh, lots of negatives in here for me to practice with. So this will become 2 plus 1 over -3 minus a -4, just becomes a +4. So I'm going to have a 3 over 1 slope, which can be reduced to 3. So I've verified that this slope is the same as this slope. So yes, I am indeed correct. So I have been able to find another point on my line. We're going to do the same thing here. I'm going to try to do this a little bit neater. My apologies for the last one. So we have a point. Here's our point. They're going to call this point 1. So P1. We know our slope. Let's plot our first point. So -1, -2, -1, -2, right about down here. And our slope is -2 over 3. And remember, our slope is rise over run. So if we have a negative rise, that means we're going down. So I'm going to go down 1, 2. And I'm going to go over 3. 1, 2, 3. So here's the 2 points that I want to use. Let me get my line tool. I'll do the best line I can. I'll try to make it as big as I can. And there is my line. So I think my other point, or my next point on this line, or point that I want to use on the line anyways, because again, there's all kinds of points on this line, is going to be 2, -4. So that's what I think I have. So let's verify this. So I got 2, -4. And this is 0.2. I'm going to use my slope formula, which we know so well now. It is y2 minus y1 over x2 minus x1. We put these things in. So y2, I have -4 minus y1, which is a -2. Negative and negative. I always had to use brackets there just to keep things clean for myself. And then we have x2, which is 0.2, which is 2, minus a -1. Put my brackets in. I think I've got this. I'm going to do an extra step here because I'm getting confused with all the negative signs. -4 plus 2 over 2 plus 1, which equals -2 over 3. And that is indeed my slope that I have right here. So I've indeed found out another point in that line. Something to think about again with negative slopes. And we have to think back to equivalent fractions too, right? And I'm going to change colors just so you know that it stands out a little bit, because this is pretty important. So if I pick this color, -2 over 3 is the same as 2 over -3. All right, so it really doesn't matter where that negative sign is. If it's negative, it's a negative slope. Okay, so if it's a negative slope, if we have our quadrants, negative slopes from left to right go down. They go down, down. Positive slopes always go up, right? Puff, puff, positive. And we want nice negative slopes. So whether we have the negative sign here, the negative sign there, it doesn't really matter too much. All right, group, that's the end of this lesson. You've had a bit of chance to practice with some of these, I think. And if you have any questions, you know where to find me. I'll talk to you soon.